Hello, everyone. Welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kyle.
And this week, we're going to talk about composition.
And composition is one of those words that you can read everywhere, but there's a lot of people that don't know what it means. Or they know the meaning of the word, but don't know how to apply the concept in code.
Exactly.
And not just beginners, because you can get very proficient as a developer and not develop a good vocabulary around the practices and disciplines and techniques. And that makes it hard for you to communicate with your peers and even read books and understand the message. So as a proficient software developer, it's important to develop this vocabulary to improve as a professional and improve the communication within your team as well.
Exactly. Composition is one of those words that is being thrown around for various tasks, and many times we use it, but we don't mean exactly what it is supposed to mean, and this miscommunication is being created, and then...
Or we use it, and we don't know we are using it.
Or that, or even that. Exactly.
So, what is composition?
Okay. So I guess the simplest term would be, think about composition as the way that you use to combine objects, right? Like it's a structural thing and you want to create something, right? Out of small components, right? So what you do, you compose a bunch of things into one, right? That's like the main idea, the gist, if you like.
So composition is the act of combining components to perform tasks or even to represent some complex data structure. And you can create tiny components that can be composed to create more complex structures.
That's it. That's exactly right. But what you just described, it's tough,
Yes.
The reason it's tough is because in order to do that, you need to have very self-contained components with a single responsibility, and they need to be able to communicate well with other components, right?
Yes.
So now we're talking about this inter-module or inter-component communication with abstractions in place, because without abstractions, we will not be able to, use and reuse the same components to create something new, right?
Exactly.
So that's like the power of composition when performed right. But this requirement is, it's pretty significant. It's hard to get right.
Yes. And you can find universal abstractions around composition. You can find monads, monoids, and even design patterns like the composite design pattern that define ways that you can compose components to achieve higher goals.
Yeah.
So you can learn those patterns in universal abstractions and create more composable code, because the concept of composition is pretty simple to understand. It's just like combining things to do something else. But as you said,
exactly,
applying those principles and achieving good composability is hard. So next question. How can you compose components in iOS and Swift? Well, there are various ways you can do it.
Yeah.
Because composability is not inherently good.
Right.
Because you can compose two objects in a very concrete way. You cannot use them in isolation.
Exactly, right?
Now you have coupling, and if you want to use just one part of that component, you cannot do it. So you want to achieve good composability, decoupling, and single-purpose components.
Yes, exactly. And as we mentioned in the previous podcast, the solid principles, that's the way to go. If you want to perform, if you want to be able to have composable objects, have composability, the solid principles are the way to go for sure. Because all the things that you need, in order to end up with a composable system, it's there, it's in there.
So if you follow the single responsibility principle, for example, or if you follow all the solid principles, you're going to end up with tiny composable components.
That's exactly right.
Or you should. It should be one of the goals.
Yeah.
So you can combine concrete types, abstract interfaces. You can compose modules, functions, and data structures as well.
Mm-hmm.
For example, if you have a user struct and it has a name, an email, and an ID.
Right.
So the user composes these three concepts in one complex structure. The ID on itself is just an ID. The name on itself is just a string. And the email is just an email. But when you compose the three, you have a more complex structure that represents a model, that represents a user for that system. But you can also compose two functions.
Of course, it's not just an OO thing, like of course you can compose functions, right? As you said, you can have these types, these monoids or these monads, and then you can compose a bunch of operations, you can chain and end up with something extremely useful with reusable components, with reusable parts of these operations.
Yeah, and you don't even need to go as far as using those universal abstractions. You can just create two isolate functions and then create a function that use both of them. They combine them to achieve a higher goal.
Yep, exactly.
So you don't need any fancy technique.
Nope.
Simply combining two operations is already composition.
Exactly. And if we can go for a second back in history, if you check out, like the Unix system, right? Or languages like Lisp and, like the modern version of Clojure that we have today, right? These systems were built with exactly these principles in mind that you are mentioning. You have these very, very simple abstractions that one component is going to transfer to another, right? So you're working with input and output all the time.
Yes.
And what's what is this simple abstraction? Data, just simple data structures, immutable data structures.
So you have data, functions, and you can compose the whole chain of operations.
Yes.
Right? You can pipe the operations.
Exactly.
And end up with very complex systems out of tiny, testable, extendable, and easy to develop functionalities.
Yes.
And that's the dream.
That's the dream. Exactly. It's beautiful.
So every time you combine multiple functionalities or data structures, you are composing types.
Yes.
And the more composable your system is, the easier it is to develop, maintain, and extend, and test, and replace,
and test,
and reuse,
yes,
and etc., and etc., and etc.
Exactly. I mean, let's ask a very simple question. Would you rather work with a class that has, 300 lines of code, or it has 30 lines of code? I think, without knowing anything else, personally, I would choose every single time the 30 lines of code. Why? Because clearly there must be less complexity in there,
It's easier to understand.
Exactly. Unless the 300 lines of code class just has a very long string there or an array, with a bunch of items. Yeah, I think that's you would want the simpler thing. And this is exactly what you get by making these very small composable components. That's the side effect. That's the good thing if you're aiming for this.
So what can you achieve with composition? Well, composition is a powerful way of getting these tiny, testable, easy to develop, reuse, and compose functionalities and data structures, and compose them in a way that you can create more complex systems and data representations. So solve big problems out of tiny, simple, easy problems.
Yes, exactly.
Why? Because tiny and simple functions are easy to test, are easy to develop, are easy to understand.
Yeah.
As you said, if you look at a class with 20 lines of code, that's probably very easy to understand.
Right.
Unless it's accessing a bunch of singletons to do the work.
Yeah, well, sure. There are these cases as well.
And if you can create your entire application out of those tiny, tiny composable types, every part of your application is replaceable, it's reusable, it's testable, it's easy to extend, develop, and maintain.
Yes. Exactly.
So if everything is formed out of tiny, simple components, it means that your entire system is simple.
Of course. Exactly. If you can do that, then yes, that's it. And it's a dream for everyone, right? Like it's a dream for developers to work on this thing. It's the dream for a business because it signals sustainability. That's the other thing that it's very important, that if you can apply this discipline and create small contributions, that are reusable, they conform to these principles, to the SOLID principles, for example, then like the end result is going to be a sustainable code base, and as long as you do these things, as long as you are disciplined, then the product, from the technical point of view, it should be excellent.
So if every piece of your code is sustainable, the entire code base is also going to be sustainable.
Yeah, I mean, sounds rational to me. That's the idea.
And tiny composable types can also be decoupled from each other, which means they can be put in different modules that can be reused across applications.
Exactly. And this is something very integral to, good systems. This separation between the business rules and then you have the delivery devices. So you can ship to any delivery device by using the same business rules, the same logic, if you like.
You can even have vertical slices in the features.
Yes.
And have different modules for different features with the business logic separated. So login can be in a login module. The checkout can be in a checkout module.
Exactly. Yes. And then you can reuse these things in different departments, in different use cases inside the company, if that's possible for you. But that's the idea. You don't write more code, you write less code, and you get more out of this thing. And that's the idea of an asset here, right? Again,
yes,
you're going to have returns without putting more, without having to put more of your time, more of your effort, more of your resources. No, you put it once and you just need to maintain now. That's it.
And you can also test, build, and deploy those modules in isolation. You can develop them in isolation, in parallel with other developers. So if you're making a change in the login module, you can run the CI server only in the login module. And that should take a couple of minutes, let's say 1 minute, to build and test it, rather than building the whole monolith every time there's a tiny change. And that can take hours.
Yes.
So I much prefer to run something in 5 minutes than 1 hour.
Again, right? It's a no-brainer.
And with good abstractions around your composable types, you can also use polymorphism and have polymorphic behavior. You can compose your types differently to achieve different goals.
Right.
So you can add and extend behavior to types without having to change it.
Exactly. So you can add or modify the behavior in the code base by using different types.
Or just composing things differently.
Exactly.
So what can you achieve with composition? Well, we can achieve extensibility, maintainability, testability, replaceability, reusability, polymorphism, and etc.
Yeah, all the good stuff, basically.
Next question. What does composition over inheritance mean? Or prefer composition over inheritance? Or why is composition better than inheritance?
So we already explained composition. As we said, composition is combining multiple components to perform a task or represent a more complex component or data structure.
Yes. Now we need to define inheritance.
Exactly. So inheritance is, and of course meaning class inheritance here, right? It refers to a language feature that allows you to achieve polymorphic behavior through extending a class.
Right. For example, you can define a class like a list view controller that you can later on subclass and add more behavior to it.
Okay.
Just like the list view controller also inherits from a UI view controller, let's say. So it's extending the behavior of the UI view controller.
Okay.
So what is the problem with inheritance? Well, the problem is that often inheritance is used to reuse code.
Right.
But that's not a good application of inheritance. Instead, you should use inheritance to extend behavior, to add a behavior or change a behavior of a class, not just to reuse a code that is in there.
Exactly. That's what is intended for, to extend the behavior, right? But then if you want to just subclass something to save, duplicating some code, then perhaps that's going to work once, maybe twice, but that can be problematic.
So in the case of the list view controller we just mentioned, imagine you have a list view controller and it fetches a list of items somehow. And you want another view controller now that also needs to fetch a list of items. If you inherit from list view controller just because of the fetching, not because you actually want to reuse all the functionality of the list view controller, then you're probably doing it wrong. Inheritance is not what you should do. Instead, you should extract the fetching logic from the list view controller into a list fetcher or something like that, and compose both controllers with the same list fetcher. Now you can reuse the fetching logic, which is in a single purpose component, the list fetcher, into both controllers or even in other types like a view model that also needs to fetch a list of items.
Yes, exactly. And that's a violation of the single responsibility principle, since you were fetching the list, the data, and at the same time managing the life cycle of the views from the view controller part.
So the problem with inheritance is that it's an all or nothing proposition. When you inherit from a class, you get all its behavior, even the things you don't want.
Exactly.
So if you have a necessary behavior in a class, you're not extending it, you're just reusing a specific functionality, inheritance is not the way to go. Put that functionality you want to reuse in another component, single purpose that only does that functionality, and reuse it across the components.
Yes.
Then you don't need to inherit all the unnecessary craft that comes with the list view controller or any other component that you want to subclass.
Exactly. And the keyword here is all, right? All components will inherit this behavior.
Well, if you want to inherit the behavior, yes, go ahead, inherit. Otherwise, compose.
Exactly. Composition might be a better choice for now.
Now, why should we prefer composition over inheritance? Or why is composition better than inheritance? Well, this principle, prefer composition over inheritance, it actually has a name.
Right.
In object-oriented programming, we call it the composite reuse principle. And composing objects is often judged better than inheritance because in most languages, including Swift, you cannot inherit from multiple classes.
Yes.
You can only inherit from one. Thus, you cannot compose with inheritance. You cannot achieve class composition with inheritance.
Exactly.
So if you want to compose types, you want to create reusable, tiny, single-purpose components, inheritance is not going to help you do that.
Yes. But you have protocols.
Yes. And protocols compose much better because you can inherit from multiple protocols, and protocols can also inherit from multiple protocols. And since you have protocol extensions where you can give protocol implementations, you can compose functionality with Swift protocols. Not every language gives you that feature.
Yes. So perhaps it's an even better option for reusing your code, using protocol extensions instead of inheriting from a class.
Yes. So prefer composition over inheritance means prefer composition over class inheritance.
Yes.
Especially in a language that only allows you to inherit from one class.
Yes.
Like Swift. And there are also patterns, as we mentioned. So what is the composite design pattern? So from the design patterns book, from the source.
Okay.
The composite pattern is used to compose objects into 3 structures to represent part-whole hierarchies. So composite lets clients treat individual objects and compositions of objects uniformly. So the idea of the composite design pattern is to compose multiple objects through a unified interface. Thus, clients can treat the composite or the composition of objects as one, even though behind the interface you can have multiple objects.
Yes. And a basic example to describe that is, for example, if you have a view controller that depends on a list fetcher, then you can have multiple implementations of the list fetcher. For example, you can have a list fetcher that fetches data remotely, or another fetcher that fetches data locally from a database. And then you can compose them into a new remote or local list fetcher. Meaning, if the internet connection fails, you can use the local. Otherwise, you can use the data freshly.
Yes.
But the awesome thing here is that the view controller doesn't know about these things. The view controller only talks to a list fetcher.
Yes,
right?
To an abstraction.
Exactly, to an abstraction. The view controller doesn't know where the data come from, nor the type of the list fetcher. And that's the power of composition here.
And as you said, you can have the remote fetcher, you can have the local fetcher, and you can also start adding even more implementations. You can have an in-memory fetcher, you can also have analytics in between, and all this behavior can be added without changing the view controller, without changing any of the clients of the interface, of the abstraction. And you can keep composing, and you can have hundreds of objects behind the scenes. But the clients treat the interface as one. It looks like one object. You're talking to one instance.
Exactly.
But behind the scenes, there's a whole composition of other types to perform the task. And all of those types should be tiny, testable, easy to develop, easy to maintain components.
Yes.
And you just keep composing them. And to achieve that, your components should not know about the concrete types they are talking to, or even create them, especially create them. All these functionalities should be injected. The components should be injected into the clients. Thus, you can compose it differently, add more behavior without changing the clients, without breaking the clients. So how do you do it? You move all the composition to a single place, to a unified place, the composition root.
That's right.
Look at the name, composition root. That's it. You break down your application into tiny composable types, and you compose all of them in a single place.
Exactly.
And that's how you achieve a clean, easy to test, easy to maintain, easy to develop, extend, replace, reuse codebase.
Yes. When you do it, you can even see this tree forming where, you can have like the view controller at the bottom, and then the view controller depends on a list fetcher, but there are multiple implementations of the list fetcher. We said you may have the remote or local fallback list fetcher, and now this has more dependencies to other list fetchers, and so on, right? So you end up with this tree-shaped code, basically.
Which is very easy to maintain. Trees are very easy to reason about.
Exactly.
The problem is when every component talks to every component and you have arrows pointing everywhere. And then you have the spaghetti architecture.
Yes, that's correct.
And that's very hard to maintain.
Yes.
Every component depends on every component. Every module depends on every module. And then you have this spaghetti of arrows going everywhere depending on everything. You cannot decompose things. You cannot test things in isolation. You cannot reuse modules across applications. Even within the same module, you cannot reuse types without inheriting all the craft they bring with them. You want a single functionality of an object But if this object does 10 things, you inherit all those 10 functionalities, even if you don't need it. So every time you change an unrelated functionality, you need to recompile and redeploy the whole module. All of the modules are going to be recompiled and redeployed. And if it takes 30 minutes, if it takes an hour to recompile, redeploy, retest your application, that's going to take an hour for every tiny change.
Yes.
So what do? You stop integrating often. You stop testing.
Exactly.
You stop building. You start releasing every 6 months.
Yep.
And you end up with liabilities.
Yes.
So that's why you need to create your applications out of tiny composable data structures, functions, classes, methods, modules. Because if you get all the tiny pieces right, when you compose them, if every tiny piece of your code is simple, testable, composable, the overall architecture is going to be simple and composable. So you need to get the tiny things right first.
Yes, that's exactly right.
And build on top of it. Solid foundation, keep building on top of it.
I mean, it's in the name, right? Solid foundation. That's like the things that you want, right? And then you have the things that you don't want and they don't contribute in a composable and pluggable system. You have tight coupling, you have, as you said, creating objects inside other objects, globals, ambient context, all that stuff. We want to stay away from those and we want to focus on the solid principles that help us build solid systems.
Yes. Starting with the tiny solid functions, solid modules, and then you go to a solid application. But get the basic things right first and build on top of it.
Exactly.
So, what are some good, valuable side effects of composability? Well, creating those assets, creating this pluggable architecture, these composable types that can be reused, recomposed in different ways to perform different tasks, to test in isolation, in parallel.
Yes.
To reduce build times, integration times, test times. Because if you want to go fast, you need to go well. You need to create those tiny composable things that can be built and changed in isolation. Otherwise, the craft is going to accumulate, and everything is going to slow down.
Yep.
It's going to come back to collect that.
Blow up at some point. Yep. Code freezes.
So you get maintainability, extensibility, reusability, and all the good traits you want in a software system, in a soft system that allows change, that can be extended, that becomes better over time, not worse.
Just think about the leverage that you have when you create such a system and you can negotiate with your business, with the company that you work with, like for something better, or with other companies. Just the fact that you are able to do these things, like you have the skills to create such an architecture, to have continuous deployment and integration, with these pluggable components. I mean, this is unbelievable. It's a tremendous asset,
Yes.
professional career asset to have. And you can, of course, businesses are extremely keen on these things, right? Like if you tell them that, we can ship basically every couple of days and never stop shipping, because the foundation is good, the foundation is solid. So we can keep doing that indefinitely as long as we keep this behavior.
Yes, so companies that know what they're doing and are looking for building assets and creating sustainable products for themselves, for their employees, and for their customers.
Yes.
They're looking for that. And if you want a remarkable career, you need to find those companies.
Yes.
And it's much easier to find those companies and get a position there when you build those valuable skills they're looking for. Because there's a bunch of companies out there. They will gladly pay you an average or below average salary to just type code like crazy and work night and day.
Yes.
And they don't care about testability. They don't care about the release times. They just keep pushing their staff to work harder and harder and harder, and not giving them training, not giving them any support to do their job. And if you're looking for a remarkable career, you need to run away from those companies. And you need to find the ones that care as much as you do.
Yeah.
And that can give you the trainings you need, that can give you the space to deliver a great job.
Yeah.
So build the skills now so you don't miss the opportunities when you find a great company, because they exist.
Yes.
There are great teams out there, and they are looking for people like you. You just need to show up.
Exactly. These assets are win-win for everyone.
Yes. So, what prevents you from creating composable components?
The usual suspects.
Globals.
Globals, number one, right? And with globals, you bring in the bad dependency management habits. Perhaps you're even creating instances inside other objects, classes. You don't want that.
Yes, because if a component creates its own dependencies, you cannot compose it with other types.
Exactly.
With other subtypes of those dependencies. You are forced to always use that behavior.
Yes.
The concrete behavior. Thus, it's not as composable as it could be.
Exactly. And then, of course, you have the solid principles. Every time you violate them, you're not going to be able to end up with composable components. And of course, ambient context.
Which is very convenient, but again, it's a global dependency. So if you want to reuse or compose a module that uses global dependencies, you need to bring all the global dependencies with it, even if you don't need it. So it doesn't make your modules or your components very composable.
Exactly. It does not, no. It's going to solve the problem right now, and you're not going to be able to extend in the future. That's the gist.
Or it still allows it, but makes it very hard to do.
Right. Sure.
You can always hack around it and create some compiler flags.
Or you can just not use it and not have to deal with all these things.
That's a better option, in my opinion.
Right there.
So you mentioned the solid principles. By violating or breaking the solid principles, you most probably are going to also break composability in your system.
Right.
If you violate the single responsibility principle, again, you have a class that does too much. You cannot use a specific functionality without bringing all the other code that comes around it.
Yes.
But if you have single purpose classes, you can pick and choose exactly the functionality you need.
Exactly. And that's a great example. And if I had to pick another one to instantly describe how you cannot have composable systems, think about the dependency inversion principle, because this is about communication between two components. So you mentioned the single responsibility principle. It describes the consistency in one component, but without being able to apply polymorphism, right? Have this polymorphic behavior that this component now can talk to any type of a specific parent type, right? Then how are you able to compose these things? You can't. You will not be able to have pluggable and composable components.
Yes, definitely your composability will be limited and it's not going to be as flexible as you would wish.
Exactly. So the solid principles are a must for achieving this level of composition, this level of composability. You need to take them seriously. You need to be mindful when you're writing code and be able to identify if you're breaking them, if you're conforming to them, and understand what are the risks. Is it something that, okay, today is fine, but in the future it might violate one of those principles? You need to be mindful. You need to know, because otherwise it's a risk that you don't want to take. It's gonna make it to the liability bucket. Why? You don't want that. You can prevent that.
It doesn't take more effort. It just takes more care.
Yes.
If you practice, you can do it even faster. If you practice applying the principles, you get good and fast at doing it.
Exactly.
And over time, if you keep the sustainable pace, you don't need to be sprinting or working over time to compensate for the mess. So overall, in the long term, you go faster. And I think that's it for today. We get this question a lot. What is composition? How can I compose types? What is composition root? From beginners and mid-level and senior developers. As I said in the beginning of the episode, you can apply those techniques but not give them names. And it's important to have a vocabulary.
Exactly.
And this is a very common question we get from our students in the iOS Lead Essentials. So hopefully we gave a good answer here. And from now on, you can add those words to your vocabulary and improve your communication with your team, and also start naming patterns and techniques you use in your day-to-day. So when you're reading a book, you can instantly understand concepts and you can learn much faster. So that's it. We'll see you again next time.
Okay. Bye, y'all.
See ya.